while a lot of you have done unit conversions before, you might have done them in different ways, and you can do unit conversions any way you want, but I am going to do them a certain way in class, and when I see you doing them a different way, if you do it wrong, I may not be able to give you as much partial credit if I don't understand how you're doing it, because partial credit is important when you're solving these problems. The process is really important. So you can do it your own way, especially if you're going to be right, but I'm going to teach you a certain way to do unit conversions. So first of all, we talked about in class today how many meters are in a mile. There are 1,700 and, whoops, that is not correct. There are 1,609 meters in a mile. So how do we write that as an equation? As an equation, we can write 1,609 meters equals 1 mile. I'm using the abbreviations for meters, which is an M, an abbreviation for mile, which is MI. If you're not sure of an abbreviation for a unit, then just write out the whole unit. But anyway, so this is how to write an equation, the conversion from meters to miles. So now, if I want to say, and how did I know that? How did I know that there's 1,609 meters in a mile? You have to look that up. So either you have to memorize it or you have to look it up. The front cover of the book has most of the unit conversions. You can Google it or you can ask Siri. But then how do we use this to do unit conversions in general? We're going to use this to do unit conversions. For example, let's say I ask you a very simple question is, how many meters are in 2 miles? Well, you can simply see the proportionality. It's good in physics. It's really important to be able to see proportionalities. If 1 mile is 1,609 meters, then 2 miles is twice that, or 3,218 meters. But how do we do that mathematically? How do we do that using a unit conversion? So if we have 2 miles and we want to convert it to meters, we have to convert it using what's called a conversion factor. The conversion factor is the factor of how many meters is in a mile. And we can go, well, say we're saying 2 miles equals how many meters. We're going to use a conversion factor. The conversion factors are going to come from these conversion equalities, right? So if we know 1 mile is 1,609 meters, 1 yard is 3 feet, 1 foot is 12 inches, right? Those are conversion factors essentially. They're conversion equalities. But we can write a conversion factor from this. So I'm going to take that 1,609 meters equals 1 mile, and I'm going to divide both sides by a mile. So let's write 1,609 meters equals 1 mile, and let's just divide both sides by 1 mile. This is mathematics. And so what this equation turns into is 1,609 over 1 meter per mile equals 1 mile over 1 mile. 1 mile over 1 mile is equal to what? It's equal to 1. That's a 1. So this is what's called a conversion factor. A conversion factor is a quantity that is equal to 1. And it allows you to convert units. And what this says is the same thing, what the bottom box says is the same thing that the top box says, which is that there are 1,609 meters in 1 mile. And the top box, well, anyway, you can see that. 1,609 meters in 1 mile. So mathematically, how do we do conversions? We could take, now we remember we wanted to ask how much is 2 miles. Well, 2 miles, we can multiply it by the conversion factor. 1,609 meters per mile. I didn't mean to write the 1,609 meters like that. But anyway, so we can multiply it by a conversion factor. And when you're multiplying anything by a conversion factor, you're not changing the value. Because what is the conversion factor equal to? The conversion factor is equal to 1. So 2 miles times 1 is still 2 miles. All we're doing is we're converting the units because we're just multiplying it by 1. And look at the units. The miles on top here cancels with the miles on the bottom. And we've got 3,218, and 18 meters is left. So that's how to mathematically do conversions. You multiply whatever you're converting by conversion factors that are all equal to 1, so you're not changing the value of what you're converting, you're just changing the units. Now, how did I know, some of you who are astute, might also say, hey, but wait, with that conversion factor, I didn't have to divide both sides by a mile. I could have divided both sides just as well by 1,609 meters. 1,609 meters equals 1 mile. Okay, sorry, I just had to meet with a student. Now I got to figure out where I was. So we're saying, yeah, 1,609 meters equals 1 mile. There's two conversion factors you can get from that. You can divide both sides by 1,609 meters. Divide both sides by 1,609 meters. And so therefore, the conversion factor you get from this is a 1 on the left. And by the way, if you're a little weak in math, notice that the 1609s cancel and the meters cancel. Letters are just like numbers in equations. So you got to treat them just like numbers. So the meters cancel. So it's 1 with no units on the left. Just like over here in the other conversion factor in this box, 1 had no units on the right. Okay, so 1 equals 1 over 1,609. Whoops, 1 over 1,609. And the units that are left are miles per meter. So this is another conversion factor. For every conversion, for every equality, there are two conversion factors. Okay? And which one do I want to use when I'm converting miles to meters? Well, you got to use the one where the miles cancels and meters are left. If I used the wrong conversion factor, so both of these conversion factors are correct, right? But let's convert, so we converted the, I don't know what color that is. Can't remember what it's called, bluish green, whatever it is. If we use the one that's boxed in bluish green, we get 3,218 meters. If we use the one that's boxed in red, we don't get an incorrect answer. Well, it depends what we mean by incorrect answer. Look, we've got 2 miles times 1 over 1,609 miles per meter. It is still a correct answer, it's just not in meters because the miles don't cancel. And so what are we left with? We're left with 2 over 1,609. You can plug it into your calculator, doesn't matter what it is what it is. And the units are miles times miles, which is miles squared over meter. So 2 miles is equal to 3,218 meters, or it's equal to 2 over 1,609 miles squared per meter. We'll just write the other one here. It's 3,218 meters, right? So 2 miles is also equal to this, is also equal to this. Which one is more useful? Well, the one we were looking for was meters, right? This one, not terribly useful. Not usually going to want to do that conversion. But you got to look and see, does this cancel? Oh, no, it doesn't cancel. Right? So they don't cancel. Okay. So how do we do a unit conversion? You have whatever you want to convert. You multiply it by a conversion factor. Multiply it by 1 in order to get what you're looking for. So, for example, let's do the example that we were doing in class at the end when we ran out of time. 30 miles per hour. I want to know what 30 miles an hour is in meters per second. So in meters per second. So how do we do it? We got to convert miles to meters. We do it one at a time. Miles to meters. So we've got 1,609 meters per mile. That converts miles to meters because mile on the top cancels and we're left with mile on the top in 30 miles per hour cancels with mile on the bottom in the conversion factor. And we're left with meters on top. So that would give us 30 times 1,609, plug that into your calculator, whatever it is, meters per hour. Okay, now we got to get meters per second. Well, so this is the conversion factor for meters to miles, and the conversion factor for hours to seconds is 3,600 seconds equals 1 hour. What I just wrote down was the conversion from seconds to hours. If you don't, well, you probably know that, but a lot of people make the mistake because there's 60 minutes in 1 hour, and then there are 60 seconds per minute, which gives us 3,600 seconds. So 3,600 seconds in 1 hour. Okay, so the conversion factor is here. The conversion factor is 3,600 seconds over 1 hour equals 1. So that's my conversion factor, 3,600 seconds per hour. So let's go back to converting 30 miles per hour. 30 miles per hour times 1609 meters per mile. Write that out again. That's my conversion factor from miles to meters times the conversion factor of 3,600 seconds per hour. And we go ahead and I did that on purpose. Hopefully you caught it. But the hours do not cancel with the hours. No, doesn't cancel. What I do, I use the conversion factor upside down, right? If 3,600 seconds is an hour, then 1 hour is in 3,600 seconds. So it's 30 miles per hour times 1,609 meters per mile times 1 hour over 3,600 seconds. Okay, so what did I do? So I looked at it, I said, oh, the units don't cancel. I must either have the wrong conversion factor or just turn my conversion factor upside down, right? There's 1 hour and 3,600 seconds. And now the hours on the bottom cancel with the hours on the top, the miles on the bottom cancel with the miles on the top, and what we're left with, meters on the top, seconds on the bottom. So that was the answer to the clicker question, but let's do it out in numbers. So you've got 30 times 1609 meters divided by 3,600 seconds, and that equals 13.41 meters per second. So 30 miles an hour is 13.41 meters per second. You might ask, how many decimal places do I carry that out to? Because the 1609 is not exact. I don't know. I think I sort of mentioned it but didn't stress it. The 1,609 meters per mile is not exact. And this is not exact either. So how many decimal places should we carry it out to? If we're doing true significant digits, then it would be 2, but I'm not going to talk about significant digits here. You're going to learn about that in lab. In general, you should, if you don't know any better, the rule is use 3 significant digits. 3 digits, 13.4 meters per second. If you use more than that, I'm okay, but if you use all 16 that your calculator shows, that's going to be a problem. You just got to be reasonable about your significant digits. You'll learn about significant digits in lab. So 30 miles an hour equals 13.4 meters per second. And we did that conversion. Now, something I want to point out here is that this is a conversion. This is a kind of conversion we're going to do all the time, miles an hour to meters per second. That's going to come up relatively frequently. If I'm driving down the road at 60 miles an hour, how fast am I going in meters per second? Well, we could do the conversion, but if I don't need a numerical answer, but I just want to get a sense of it, just notice that meters per second is it's not exactly, but it's about half of miles an hour. So 60 miles an hour, about 30 meters per second, right? 100 miles an hour, about 50 meters per second. How fast does a plane fly? 500 miles an hour, about 250 meters per second. Okay, so I'm not going to do much else with unit conversions because you can always look up You can always look up conversion factors, right? 60 seconds equals 1 minute. I don't know. 1,000 grams equals 1 kilogram. 1,760 yards equals 1 mile. Those are all the conversion equalities, or you can call them conversion factors, and then we can turn them into conversion factors, right? So 1 over 60 minutes per second equals 1. So now it's a conversion factor, right? 1,000 grams over 1 kilogram equals 1, et cetera, et cetera, et cetera. So we can create conversion factors, and then you just look at the units, and you can, whoops, that was not gram over gram, but gram over kilogram. And you can turn one unit into another unit by using these conversion factors. Now keep in mind that our base units, the units that we have to understand, are meters, kilograms, and seconds. So everything's going to be written in terms of meters, kilograms, and seconds. And so then we just need to be able to convert those into other things, right? Seconds to minutes, seconds to hours, minutes to meters to miles, meters to yards, meters to feet. You can look up the conversion factors or figure them out. Kilograms, grams, I got stuck on that one because there's not a whole lot of different ways of measuring mass. Be careful, right? This is length, this is mass, and this is time. Length, mass, and time. Those are our base units. Base units. Everything is going to be written in terms of those. So our conversion factors are typically in terms of those. Sure, you can get a conversion factor for other things. Joules to, another unit of energy? Calories. Joules to calories, right? There is going to be a conversion factor for joules to calories in energy units. But you don't necessarily... You could look up the conversion factor from, you could turn these into their MKS equivalents and then, and put them in terms of meters, kilograms, and seconds and then do the conversions. But, you would probably more likely just look up joules to calories and use that conversion factor. But what I'm trying to say is you can always put things in base units, meters, kilograms, and seconds. Okay, so the lengths, I think we get that. The time, the masses, I just want to focus on the masses a second because often people will ask me, how do I convert pounds to kilograms? How do I convert pounds to kilograms? And the answer is you don't. Why don't we convert pounds to kilograms? I can just hear the answers now. You're telling me because they are not both measuring mass, right? The conversion factors for length are lengths to lengths. The conversion factors for time are times to times. The conversion factors for mass are masses to masses. And pound is not mass. Pound is weight. Pound is weight, right? So we don't. So that is something that you got to be really careful about. Don't ask me how to convert pounds to kilograms because there is no conversion factor. What you can ask me is how much does 1 kilogram weigh? A kilogram does have a weight, but mass is not the same as weight. Now, if you don't know that, we'll talk about it later. Mass. Sorry, it's a little messy, but kilogram is mass, pounds is weight. And mass is not weight. So we cannot convert from one to the other. They are two completely different measures. We'll talk about that very soon, but not right this second. But how much does 1 kilogram weigh? 1 kilogram weighs 2.2 pounds. LBS is the abbreviation. 1 kilogram weighs 2.2 pounds, and people will often use that like a conversion factor. 1 kilogram equals 2.2 pounds. It's not a conversion factor because it's not really equals. 1 kilogram weighs 2.2 pounds. I'm going to put that in quotes because it's not really correct. Okay, let me think about one or two more examples that tend to mess people up. For example, when we're talking about volume, let's say volume. Let's say that I have a container of water, a bottle of water, right? A bottle of water. Speaking of something to drink, a bear walks into a bar and says to the bartender, "I'll have a pint of beer and a packet of peanuts." The bartender asks, "Why the big pause?" Okay, so you didn't like that one? Let me try another one. A gorilla walks into a bar and says, "A scotch on the rocks, please." The gorilla hands the bartender a $10 bill. The bartender thinks to himself, "This gorilla doesn't know the prices of drinks," and gives him his 15 cents change. The bartender then says to the gorilla, "You know we don't get too many gorillas in here." The gorilla replies, "Well, at $9.85 a drink, I ain't coming back either." Okay, let's get back to our bottle of water rather than a scotch on the rocks. All right, so let's say we have a bottle of water. Let's see if I can draw a bottle of water. Not a very good bottle of water already. Okay, in any case, we have a bottle of water, and let's say that the bottle says it's 0.5 liters. The volume, that's volume, the volume is 0.5 liters. Liters is abbreviated a little L, but anyway, we'll just write it out, 0.5 liters. And let's say I ask how much volume is that in other units, in MKS units, let's say, or in metric units. So I'm going to look up the conversion for liters. Okay, so I'm not sure, so I'm just going to ask Siri, how big is a liter?
That would be 0.26 gallons.
Okay, so Siri gave me 0.26 gallons. Well, okay, that's another unit of, that's a unit conversion, 0.5 liter, I'm sorry, 1 liter is 0.26 gallons. Whoops, 1 liter is 0.26 gallons. So half a liter is 0.13 gallons. Okay. What about I said MKS, so let me ask Siri for MKS. How many cc's in a liter?
1 liter converts to 1,000 cubic centimeters.
Okay, so Siri told me that 1 liter is 1,000 cubic centimeters. cc or cubic centimeters. Cubic centimeters means centimeters cubed. Just in case you're not, your math is a little rusty, centimeters cubed means centimeters times centimeters times centimeters. Okay. So it's 1,000 centimeters cubed. Now, why did I ask for cc's? I could have asked for cubic meters, but cc is a typical measure of volume for these kind of sizes, because 1 cubic meter is a large volume. So cc is more of a natural unit, what we call a natural unit. But I asked for MKS. So we want to find out how many liters, what liters equal in various metric units, including MKS. So if the volume of the water is half a liter, then therefore, since the volume of the water is 0.5 liters, we can say, oh, there are 0.26 gallons in a liter, and so therefore it's 0.13 gallons. Okay, that wasn't MKS. Or we can do 0.5 liters, and we can multiply that by 1,000 cc's, or cubic centimeters, it's the same thing, over oops, I keep writing it wrong. That's a till. Okay, try again. 1 liter. The liters cancel, and we're left with 500 cubic centimeters. Okay, so half a liter is 500 cubic centimeters. Okay, just using the conversion factors, using the conversion equalities, turning them into factors by dividing one side by the other. Okay, but what about cubic meters? So 0.5 liters equals 500 cubic centimeters. What if I want to turn that into cubic meters? MKS, right? Meters, kilograms, seconds, cubic meters. Well, I have to turn centimeters into meters, right? So how many centimeters are in a meter? We want the meter to replace the centimeter, 1 meter on top, 1 meter on top, and how many centimeters are in a meter? Everybody's yelling out 100 centimeters. 100 centimeters in a meter. Okay. But notice, and this is super important. Please pay attention. This is where people mess up, is that this centimeters on the bottom, let me change colors. This centimeter, oh, that doesn't work. That was supposed to be a highlighter. Just crossed it out. One more time. This centimeters on the bottom cancels with only one of these centimeters. Remember, these centimeters cubed is centimeters times centimeters times centimeters. So it only cancels with one of them. So what we would get from that conversion is, we get this conversion, 500 over 100 centimeters squared meter. So it's 5 centimeters squared meters. That is a valid volume. It's just not a volume that we're used to seeing. So we've got to do this conversion 3 times. We've got to convert all 3 factors of centimeters to meters. So how we do that is, I'm going to do it on a new page. So I've done it out for you here. 0.5 liters equals 500 cubic centimeters. We got to convert each of the centimeters to meters. 1 meter over 100 centimeters. Multiply that 3 times, and so what we get is 500 over 100 times 100 times 100, which is 1 million, and we're left with meters cubed on the top, and the centimeters cubed cancels with the centimeters cubed. Another way of writing this is, instead, what I could do is I could forget that, just cube this, right? If I cube that, right, then I've got 100 centimeters cubed on the bottom and 1 cubic meter on top. 100 cubed is a million. Either way, we get 500 over a million. Now, in this class, we have to use the scientific notation. You must use scientific notation. You must. So it is going to be 500. It's okay if it's 3 digits, but if it's more than 3 digits, you got to use scientific notation. So it's 500 over 10 to the 6th meters cubed, which is 5 times 10 to the minus 4th meters cubed. That's the kind of math which you may not be greatly comfortable with, but you've got to be able to utilize. You've got to be able to figure out for yourself. 5 times 10 to the minus 4th meters cubed. So half a liter is 5 times 10 to the minus 4th meters cubed. That is not in scientific notation. 0.0005 meters cubed. It's a very small volume. It's not a very small volume. It's a bottle that's sitting in front of you, but it's a very small amount of meters cubed because a meter cubed is a large amount of volume. So that is all I'm going to do about unit conversions.